Okay, so we start chapter 4 last time. We're going to finish it up today. We talked about the function calls. We talked about the top-down design, predefined functions, programming defined functions, and we're going to finish it up with the procedural abstraction, local variables, and overloading functions. So what do we know about the top-down design? Are you guys ready back there? You want me to wait for you? What is a top-down design? You're going to start with a task and you're going to break it down to the smaller tasks. Why do we do that for? Easier to understand, easier to change, easier to write, easier to test, easier to debug, and easier to teams to develop. So we're going to be working with a smaller project. We are not working with a big one. So that was the concept of a function. So when you guys writing function for your assignment, you are not supposed to make 2, 3, 4 functions of doing the same thing. You're going to have one function and you're going to keep calling it. So predefined functions. What are the predefined functions? So what is it? Those are the functions that's already been created. So we don't write, we don't create it. It's already done. So we're going to be using it, right? So for that we have to use what? Pound include. Remember, this is going to be in your test next week on Wednesday. So maybe it's about time to start reading this stuff. So something like the square root or functions like that that's available. But if we want to use those, we got to do what? We got to use a pound include. We have to know what is the code and put it in there. For example, for a square root, we need the CMAT pound include. So we talked about the ABS, FABS. So in this one, we're using the SRAND. SRAND is want to use the time 0. This is for random number generator. So we are needing the pound include for the time. So that's going to give us the time on the machine. We're going to use that one. We're going to put it as a SRAND for a seed for the function that's going to be rand. So we're using 3 functions over here. That's all predefined. It's already being created. And we need those pound includes to be able to use those. There is another some other variables that's going to be defined as well in those codes. For example, rand underscore max is going to be part of that cstdlib, which is going to define what is the maximum number that I can have for this, which most likely is going to be the maximum number I can have for an integer. So if I have a number from 0 to 5 billion or something like that, then how do I get it to do 1 to 6? Remember, the percent is going to give you what? The remainder. So if I get any number and I do %6, that's going to give me what? 0, 1, 2, 3, 4, and 5. It doesn't give me anything else beside that. So if I add 1 to it, that's going to give me 1 through 6. So that can be used for that the dice. Actually, I didn't assign that to you guys. But if I want to roll a dice, I need 1 through 6. That's the way I want to create it. But of course, I have to do what? The pound includes. I have to create the SRAND. And then I'm going to use the RAND over here to be able to get 1 through 6. So how do we do 2 dice? Okay, we can do that. That goes from 1 to 12, or we can do this 2 times. Die 1 is going to give me 1 through 6. Die 2 is going to give me 1 through 6. So remember, I can call these things 2 times. Generating a random number x where x is between 10 and 21. How do we do that? So it's going to be greater than 10, less than 21. So that's how many number is it, first of all? 11 to 20, that's going to give me what? 10 numbers. Is that 11? 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's going to be 10 numbers. It's going to be 10 numbers. So that percent is going to be what? Right here is going to be 10, right? I need 10 numbers. That's going to be 10. Now, what number do I get after that? So we're going to add 11. I don't want to start at 10. I want to start at 11, right? Because if I remember, it's going to give me 0 to 9. So if I put 10 over there, it's going to give me 0 to 9. And if I add 10, it's going to be what? It's going to be 10 to 19. But then I don't want 10, I want 11. So it's going to be 11. That's going to give me the number. So I'm going to have 10 numbers starting with 11 to 9 to 20. So we went a little bit about this. We talked about the static cast. That's the way we're going to change the data type. So we can change from integer to double, double to integer. Once again, integer divided by integer is going to give us the integer number. And keep in mind how many times I'm repeating this. Still the last time, half of you guys didn't put it correctly. So that would be a good candidate for the test, right? So the total of total candy is what? 9. 9 divided by 4 is going to give me what? 2. Does not give me any decimal number, even though I define this as a double. So I need to typecast one of them. If I do force one of them to be double, the other one is going to follow. So all I need is 1 in the calculation, and then the system is going to promote the other one. So if I have one of these to be double, the other one is going to be promoted to double also. Yes, sir. Say what again? Yeah, if any of them is going to be doubled, that's correct. Any of them can be doubled, we're going to be okay. So what we're doing right now is, because they are not double, they are integers, then we have to force it to be doing that. Where did you see that in your homework? That you're dividing integer by integer. That was extra credit on 212, that you were getting 10 integer numbers and you were supposed to find the average. Some of you didn't do it correctly because you were dividing by a number. So if I have 25 divided by 2 or 10, that would, what is 25 divided by 10? 2. Good, Roshan. So if I put it outside, this division is going to happen first. The division is going to give me an integer. That integer is going to be forced to that one. So 9 divided by 4, that's going to give me 2. The static cast of 2 is going to be 2.0. The candy per person is going to be 2.0. Maybe that's what I want. Maybe that's what I want. I want to not give them a fraction of a candy. If that's what I want to do, that's what I want to do. This is the old-fashioned way. That's the way I am used to it because I don't want to type all those typecast and all those things. But as it says over here, it might go away. So till it doesn't go away, that's the way I'm going to be using it. What is the other way of doing it? What is the other way to doing it? You can multiply one of these by 1.0. Remember, if you're doing any kind of a calculation, it's going to promote that. So if I multiply total candy by 1.0, that's going to be double. And because this is double, this is going to be promoted to double. Remember, this is going to happen only one is doing the calculation. It's not going to affect the total candy or number of people. They're still going to be staying as an integer. We did this. So 11 divided by 2 is 5. What did you say? 11 divided by 2 is 5. POW 2 to the power of 3. 8. That's going to be 8.0, right? Some compilers are going to complain about this because it's expecting a double. If that's the case, we have to change this to double. Some of the compiler doesn't like, because originally it's supposed to be double. Some of them is going to be taking this and it's going to promote it to double. Some of them is not going to do it. It might give you an error. So if that's the case, you're going to put 2.0, 3.0. What is FABS minus 3.5? 3.5. POW of 3.2 is going to give me what? 9. 3 to the power of 2. Was the math 9 required for this class? Okay, you did the whole thing. Okay. POW of 3 to 2 is going to give me 9. The square root of that gives me 3. That's good. That was good. 7 divided by absolute value of 2. 3. Ceiling of a 5.8. 6.0. Floor of 5.8. Okay. And a square root of x plus y. And we do not have 2a in C++. You have to say 2 times a. So you guys start doing your homework. It was due, I guess, tonight. We were supposed to do, no? Wednesday? Okay. Two hours. You have 2 hours to do it. Okay, so it's due Wednesday. So we have the functions that we're going to be creating ourselves. Okay, so the key is what? We're going to have a function declaration, we're going to have function definition, and we're going to have function call. So this can be tricky for some of us. We haven't seen it before, so we're going to spend some time on it to be sure we understand it. So the declaration is going to be on top of the program. It's going to have the name of the function. It's going to have the return type, and it's going to have the parameter. Once again, on the top, the declaration, it does not need to have the variable name. As far as it says int and double, it's going to be okay. The key factor is that semicolon. Do you have a guess that maybe that's going to be on the test? So did anybody tell you that you're not supposed to use your text messaging in the middle of the class? So we're going to put some comments in there. That's going to explain what is that the function going to be doing. That is the declaration on top of the program. Then we have the function definition. Function definition is going to be what? It's going to be saying what is this function going to be doing. So that is going to be return type, the name, and the variables. For me, it's always easier to copy this one, put it on the top, put a semicolon, and that would be my declaration. So I don't have to worry about it. I just copy that line, put it up there, put a semicolon. Declaration has a semicolon. Function definition does not have a semicolon. The variables that created over here is going to be local, meaning that if as soon as I hit this one, all these variables created here is going to go away. But the idea of this is what? It's portable. I can take this one, put it anywhere else, it's going to work. This is called function body. I am used to create a variable and do just the return of that variable. I would create extra variable here. I would put that one in there and return my total cost. But this is going to work also. So we can have a return statement, or we can have it as a void that does not return anything. We can have it like this. We can have a parenthesis around it, or we can have a variable defined and just return that variable. So something that you want to study for your test since you are here. If I have return 2, 5, figure out what that's going to happen, because that question is going to be in your test. You figure it out. That's going to be on the test. So, okay, the function call. Now we have our declaration. We're going to have our definition. Now we're going to call it, because if I have declared it and I have the definition, doesn't mean it's going to do anything. I have to call it in the program. So when we're calling it, it's going to match up the first one and the second one with it. It's going to check the types of this one on the declaration to be sure we have the correct types. Right now we are going to be using a call by value, meaning that when we're using that one, it's going to make a copy of that variable. It's not going to touch the variable. It's going to use with the copy. So whatever happens to that variable inside the function is not going to be happening to actual variable that we had from the calling area. We can call a function through another function. It is not a good style. It's called the spaghetti style, that you're going to be calling and calling somewhere else, going to calling somewhere else. So I have my declaration. Where's my declaration? It's not here. What would be my declaration? I would just copy this line and put it on the top over here. That would be my declaration. What else do I need to do? Semicolon at the end of it. So it's going to have this number that has been read from the user, and then I have the price that's been read from the user. So I have a number and a price. The number has a value of 2. The price has a 10.10. It's going to pass it on to the first one and the second one. It's just going to call it. So it's going to go in here. It's going to do this calculation. It's going to do this calculation. It's going to come up to 2121. It's going to replace this whole thing with 21.21. Remember, the number was copied, passed through. Price was copied, passed through. So anything happened to here with the number and the price, nothing is going to affect my number and price that I had in here. So this whole thing is going to be replaced with 20.21. Then we assign it to Bill and we move forward. Yes, sir. That's a very good question. Okay. What happens when we change the price with a number? What's going to happen if we change the price and a number? We don't know about it. It's just going to, right here. Oops, I went back. Okay, here. So if I switch it, the computer is going to know what? I have the first one and the second one. It doesn't know what you call. That's why your book is going to change the names. So it does not matter what I say. So when I say int receive is 95 and minimum score is 60, and I'm calling the grade with minimum score, which is what, 60, and received, which is 95, that's not what I wanted, but it's not going to happen. It's going to check the first one and the second one. Because both of them are integer, it doesn't know the difference. Remember, in my declaration, I do not need the variable. It's just int and int. So if I mix it up, it's just going to use it that way. That's why the comments are very, very important. Okay, for those who are not putting the sample run on the bottom of your programs, you're supposed to have this on the bottom of your program. Okay, now when we are talking about function definition, where is my function definition? Where do we start writing our function definition? In the bottom after the closing braces of main. Good. So we have variables must be declared before they are used. These are called the local variable. They're going to go away. So if I have the same name inside my main, it does not matter. Variables are typically declared before the executable statements begin. That means we are used to define our variables before we use it. So we're going to have a section of declaring our variables, then we're going to do our processing. At least one return statement must end the function. It says at least one. You can have multiple return. Then it's going to return at that point. Each branch of an if-else statement might have its own return statement. So I can have multiple ones, and if I get what I want, I'm just going to get out. The old-fashioned way was we were putting all the definition on top of the program. So if I want to start looking at my main, I had to go find it on the bottom of the program. Then they change it to this convention that having a declaration on the top, the definition on the bottom. Now that I have a main, I'm going to be looking at the main right away. Our main is going to be very, very, very small. It's just going to be calling other functions. Boolean return value is going to be able to return false or true. The AND always happen before the OR, but if I want to be sure that I don't have to think about it, or the future people don't want to think about it, I'll just put parentheses around it. This way I'm sure that whatever is inside this parenthesis is going to happen first, then the OR is going to happen. So this is going to be useful for what? If I'm dividing by a 0 or something like that, I want to be sure that I'm catching it. I don't want to divide by 0. If I have a function like that, I can use it in my if statement. If appropriate rate, that means it's going to be greater than or equal 10, less than 20, or rate is equal 0. So we can create a function, and this is going to be just the definition of my function. It's going to be a returning Boolean. It's going to take one thing as a rate, and it's going to check the rate to be sure it's in this situation. So my declaration is going to be this line with a semicolon at the end, and this the whole function is that one. This is something that might come to your exam, things like this. Okay, so when we're talking about the function, we can think about it as a black box analogy, meaning that the user that's going to be using my function does not necessarily need to know all the elements of my function. I don't even have to give the next programmer my whole code. As far as they know what is the parameter, what is it doing, they can use it. I will create functions that other people can use it. It's going to have enough things in there, and I'm going to have enough comments for them to use it. So if I am driving a car, I learn how to drive the car. I do not need to know how the engine works. I don't need to know what the electricity in there works. I just turn on the light, and that's all I need to know. So the same concept goes here with the procedures or functions, that they don't need to be in detail for the future programmers. But I have to be sure that they have what they need. So what is it that they need? They need the declaration to know what is it going to be using it. And they also need the comments on the top. But they do not need the body of the function. I can put that one in another file and compile it. So they have the binary code, but they don't have the source code. That way they cannot go and sell it. So why do we do that? It is to change or improve a function definition without forcing programmers using the function to change what they have done. So we can always upgrade those things. So every time we are hearing about some upgrade happen to the software, that's the way we send it to them. To know how to use a function simply by reading the function declaration and its comments. So it is very, very important to have the comments on the top. For those who don't like to write, just like myself, we have to do these things. This is part of the programming. We don't like it, but that's the style. That's what we got to do. Yes, sir.
Is there any way for us to add functions that we write to like the C standard library?
You're going to create your own library. And then you're going to do a pound include of your own file. So if I call it my file.h, whatever you want to call it, you put those things in it and you compile it with your project. So it's going to be separate.
Where do we store those?
Okay. The way that it's going to happen, it's always going to start looking at the same directory. If it cannot find it, it's going to go up to the path that you have in the computer. So wherever the path of your computer is, you can define that in your computer. So it's going to go and look at those directories. So starting from the local directory, that's where you start. Then you can put it in the library because it's going to go and look at the library.
It should be in the same folders for these.
Yes, for now, yes. Yes, sir. What is the difference between definition 1 and definition 2? So those are exactly the same thing. The only difference is what? I have a variable. This is the way I'm used to it. I have a variable. I'm doing my calculation. I return the variable. Or I can put the whole thing over here. That's the difference. To me, this is a little easier to read. I don't know. Maybe that's the way I'm used to it. I wrote the program like this for 20 years. So that's the way I'm used to it. I don't know. But that's the difference. So when you're writing your program for the assignment that's asking you to calculate for next year and 2 years from there, you do not create two functions. You're going to be using one function for that area. So you're going to have two functions. One is going to calculate your rate. The other one is going to calculate the price for next year. You're going to call the same function to calculate the price for the following year. You do not create two functions for that. You're calling the same function 2 times. Or, to make it better, you can put a year in there. So depending to the year, you're going to calculate for that. So for 1 year, I'm going to calculate for next year. If I put 2 in there, I'm going to calculate for 2 years. If I put 3 in there, I'm going to calculate for 3 years. So the concept of the function is what? Reusable code. So if I have 100 of them, I'm not supposed to write 100 function. I'm going to be using the same function. So you have to have a function that's going to be general enough that you're going to be using it over and over. So we're going to have the procedure is the general term, meaning a function like set for instruction. So abstraction implies that when you use a function as a black box, you abstract away the details of the code in the function body. So you're not showing it to the next person. So we have the function comment should tell all condition required of the arguments. Remember, your future person that's going to be looking at your code does not have the body of your function. So everything that person needs has to be in the comment section of your declaration. Function comment should describe the return value. What is it they're returning? Variables used in the function other than the formal parameters should be declared in the function body. So when we have parameter names, it does not have to match with it in the calling function. Remember, I can take this function, put it in other programs, and it's going to work. Your book has a way of writing PAR for parameter. You can call it the same thing if you want, doesn't matter, but it doesn't have to be the same. So this is my declaration with the semicolon, with the comments of explaining what is this doing. That's the style. My function definition. That's going to be a good question for the test, huh? To give you something to write your declaration and the definition for something like that. So the total cost would be int number double price, and so when we're calling this, where do you go? So I don't have to have this number and price over there. But since I don't want to type, I just copy and put it over there. So now we're doing the top-down design. We're looking at the requirement of what size pizza is the best buy. We're going to give the size and then the price. And we're going to check it the unit price. Okay, so every time we're writing a program or a function, we have to know what is the input, what is the output, what is it doing. So IPO, input, processing, output. Usually we divide it like that logically anyway. At the beginning of my program or my function, I'm going to have my input. At the end of my program or my function, I'm going to have the output. In the middle of my program, I'm going to have the processing. So I'm going to read whatever I need to read. I'm going to calculate, do my calculation, my processing, and I'm going to output whatever I need. So breaking it down into the smaller task, we're going to get the input data for each size of pizza. We're going to compute the price per inch for a smaller pizza. We're going to compute price per inch for larger pizza. We're going to determine which size is the better buy. We're going to output the result. So first is input, last is output, the middle is the processing. That's my input, output, processing. Now when I start writing the definitions for these functions, then maybe I can say maybe they can put these two together if I do it correctly. So if I change the variables, the subtask 2 and 3 can be combined as one function. They don't have to be separate one. That's exactly what you're going to do with that finding the cost or price for next year and price for 2 years. It's going to be exactly the same thing. We guys just pass the different variables. So once again, we're going to put the declaration for the unit price. We're going to have the int and int. We're going to explain in detail what is this doing. So we have the subtask 2 and 3. What do we need to do for that? We need to compute the radius of the pizza. This is called pseudocode. We are writing something in that matter, or at least in the English type. What is it that we want to do? We're going to take it and make it pseudocode, and then we're going to create the code out of that. So the pseudocode is a mixture of the C++ and English, allows us to make the algorithm. Remember, in this up to this time, I'm not writing any code. My concentration is not my code, if it's going to work or not. When I start writing code, my focus is going to be on how to make my code work. In here, my concentration is what's the best way of writing the code. So my focus is different. So for example, in here, I am focusing on the pseudocode for this section. So it's going to say radius equal 1/2 of diameter. Area is pi times the radius, or I can say to the power of 2, and return price divided by area. As soon as I see a division, I check to be sure these two are integer, not integer. If they are integer, I have to worry about it. Every time I see a division, I check automatically. Is this integer divided by integer? So the main part we're going to be calling other ones. Yes? Yes. When you're having any kind of calculation, only one of them has to be double. So in my main, I'm going to be just calling other function. So if I have a unit price, one function, I can call the diameter of a small and the price of a small, and I can call the same function with different variables. So it's going to calculate this one for me now. So all I have to do is just change my input. My output is going to come out different. I do not need two functions for this. So the unit price, I can put this pi on the top of my program, but when I put it right here, it's going to make it portable. Whatever it needs is right there. Const, we're going to put conventionally, we're going to put it all uppercase. So this const double pi is going to be here in this function. So if I take this function to somewhere else, I don't have to worry about any dependency of this function to any variable that I have in the program. It will need diameter, it need the price, it will return the unit price. What does it say on the bottom? What does that mean? What type is the diameter? Diameter is integer. 2 also is integer. Integer divided by integer is not going to give me a double, it's going to give me an integer. Remember, every time you have a division, you have to check it. So we have to change the typecast of one of these, either this one or that one. Once again, it's not going to affect it, it's just going to use it right here for that. Now it's going to be, this calculation is going to happen in the double. Declaration on the top with the semicolon, the comments, then we're going to call it 2 times. This is what you're going to do with the assignment. We can potentially put this one in a function. So it would do all this in a function. We could do this in a function. So a typical program, a good programming style would have one function call here, 2 function call here, 1 function call here. Very, very small. So even if my program is running, doesn't mean it doesn't have bugs. It doesn't mean it's correct. So we have to go back and test it. The best way to do it is to write a main program that's going to be testing one function at a time. That way we can test that function to be sure that's working with some test data. We should be writing a pseudocode to be sure that we are focusing on the design of the program instead of worrying about the code itself. That's something to worry about next Wednesday in your test. Right? Okay. Next section is talking about local variables and the scope of that. That means if I have local variables, they go away as soon as we hit the braces. So the scope of that is in that area. Variables declared in the main part of the program are local to the main part of the program. They cannot be used from outside of the main. Okay, so I have a double right here. It's called average P. Okay, once again we have the declaration on here with the semicolon with the comment on it. Now, I am going to be reading in average P, okay? And I'm going to be multiplying it over here, and I'm going to be using it over here. So these ones are going to be what? It's done in the main, right? So if I use the same variable inside of my function, I don't have to do it, but if I do this, what's going to happen as soon as I call this one, my function call is right here, right? As soon as I call this one, physically, it's going to go to different part of the memory, and it's going to start executing this function. So it's going to create, it's just like a little program that's going to be running in outside of the other program. So it's going to create its own space. It's going to create its own average P, and it's going to do this calculation. As soon as I hit the braces, return, that is going to go away. So this is not going to affect the other one that I had over here. So meaning that this average P is different than this average P. We can define these things in global. That means we're going to put it outside the main. But the problem with that is what? My functions are going to be dependent to this one. So if somebody want to use my function, they have to have that in their program. Otherwise, my function is not going to work. So for those of you who are using a lot of global variables that is outside the main, that is not a good style of programming. We do not like to see global variables because that makes your program, everything in here, dependent to that. That means I cannot take those pieces and move it anywhere else. My program is not going to be portable. So that pi has been used in this function, has been used in this function. But once again, I cannot take this function and put it in another program that works. I cannot take this one and put it somewhere else that's going to work, because the pi is defined over there. So it's a good idea to define it over here to make my functions portable. So we can have a constant or we can have a variable on the top. Generally make program more difficult to understand and maintain. Do not use it. Formal parameter are local variables, so we can have it in the functions. Once again, if I have it over here, it's not going to change it because we are passing by value. Next chapter we're going to learn how to change it, but right now we are not changing it. So this minute's going to make a copy, it's going to go here, it's going to come out. But that minute is not going to change. A copy of it is going to be there. So if I put something in a block, the scope is going to be for that block. So if I declare something here, this is my block. I'm declaring I over here. So if I had another I over here somewhere else, that would not be affected. In here I have X, and I'm using it over here. But in this case, I am declaring my Y over here. That means this Y is going to go away as soon as I hit over here. This X is using this X. So what's going to happen? The value of X can change. That's why we're using the int over here, because if I was defined somewhere else and I had some value for the I somewhere else, then it would change it over here if I didn't have the int. But if I put an int over here, it's going to use this I locally over here. As soon as I hit these braces, this local I is going to go away, and if I had another I over here, that's going to be used after that. So we are doing the namespace. We used it earlier using the namespace std. Why are we doing that? Because we want to type less, and basically different functions may use different namespaces, so we can put those things inside the functions instead of using it on top of the program. I'm not worried about it right now. You might get into it later on. So we might have this user using namespace std here for our cin, cout. Or we might have it in the function also. So there is another example. That's the one of the good thing about this book is these examples that you have in there. So for the factorial, we're going to be writing down what is it supposed to do. So we're going to create a function, and we're going to do that inside. So we're going to be doing this while loop inside this function. Later on, you're going to learn a recursion, which is going to be called, this function can call itself. Well, right now we have a loop that's going to be doing it inside here, and it's going to return the value product. So C++ allows more than one definition for the same function. I can have the name of the function to be the same and behave differently. That's called function overloading. Same function name doing differently. For the computer to understand what is it that I'm doing differently, it has to know that they are different. So even the name is the same, it has to know how they are different. There is two ways of knowing they are different. One is the number of the parameter. So even if this function is the same name as this function, this has two parameters, this one has three parameters. So when I'm using it with the three parameters, it's going to go use this one. It's not going to use that one because it knows it has three parameters. The same name, different number of parameters. This is the definition. This is the definition. We will have a declaration of this on the top of the program. So either they're going to have a different number of formal parameters, or they're going to have different types. So it's going to match up. If I have the same name with the same number of parameters, this is my declaration over here. So I can have two of them with the same number of parameter, and instead of double and double, I can have int and int, or character and character, or a string and a string. So it's going to be the same name, number of parameter would be the same, but they have different data type. So either they're going to have different data type, or they have different numbers. So the computer knows which one is the one is doing calling. So this one is calling with the double, it's going to go pick up the double. This one is only 2, it's going to use this 3. So if I had integer over here, it would force it to go for an integer, it would give some kind of a warning for it. So I have a unit price that's going to take length, width, and the price. So the unit price and the unit price, same name. They're both returning double. This one has 2 parameters. This one has 3 parameters. So depending on how I'm going to call it, if I call it with the 2 things, it's going to pick up the one with the 2. If I call it with 3, it's going to pick up the 3 one. And of course the definition of them. So if I only have 2 parameters and is expecting a double, it will use the integer, it's going to promote it to double. But if I had 2 parameter with the integer somewhere else, it would go use that one. It's only going to use the automatic typecasting if it doesn't have it somewhere else. So if I had another one that had integer and integer, it would go use that one. If I don't have it, it's going to force it into this. Your compiler is going to give you a warning, but it's not an error. Sometimes what's going to happen is you're going to be using the same name, but it's going to be doing totally different things. But that's not suggested because the name of the function is important for the people to use it. So if I have MPG, that's going to be mile per gallon. That's what the function is going to be doing. So if I use my MPG for my purpose, going something and doing totally different things, that's not suggested. And that's going to be questions for your test. Questions on chapter 4. Once again, the test is going to be on Wednesday. I have decided not to do it multiple choice that many. You're going to have some of them. But since some people were talking on the test and not paying attention to their own test, now everybody's going to have a hard time. No, next Wednesday. I'm going to add some more assignment for you. You can have some assignment. I mean, what do you want to do? Do you next Saturday or Thursday? I don't know. We're going to figure it out. So no, you're going to do some assignment. You cannot not do any assignment. That's the way you're going to learn. You're going to get ready. Let me see what I'm going to do with the. I'm going to do the roll call. I haven't been doing that for a while. Any questions? No. I'm going to have you write some programs. Some of it. I don't know. That's going to be chapter 3 and 4 of your C++, chapter 2 of computer science book. It can be open book. Maybe you should do it closed book, huh? Because open book makes people not to read.